Good morning, everybody, on this fine Monday. It's September 16th, and I got a little show for you that is private for now, but it'll be shared with you later at the appropriate time. Had a working dream, if you will. I was awake, but waking dream, I guess you would say. And I was working with the logistics in my mind's eye in dream state of the possibilities with what we're learning from the Model T buzz box or spark coil. And there's so many things that's interesting when you apply that technology, the capability of an electrical array, if you will, that unit generates. And so anyway, the main focus that happened during this dream was understanding the center point, the zero plane. And in mathematics, in my formal education, zero was denoted as infinity. And then the horizontal plane from connecting 2 points. And however, when you get into the PMH magnet, in the magnetic field of iron, ferrous material, that denotes the iron age. Ferrous material is what conducts the iron. That's the cool thing about iron, is just a little bit in memory, getting down to the Planck level and then on up to the atomic level. Just a little bit of iron is affected by the magnetic field, and it has a control sequence that you'll hear me talk over and over and over again about my studies and relationships and anything to do with electrical properties. When you really get back to studying those things, you'll find the same thing that I find, is that there is a creator, okay, and in this construct. And the more you try to go other directions as far as our literature and everything, you're gonna come up that there is a creator that created everything in this construct. Where I live part-time, I live in this construct quite a bit. In the old days, I used to live in this construct 18, 19, 20 hours a day. And as long as I get 3.5 hours sleep, I've always been fine to go. But like you'll hear me say, when we sleep, we leave this construct, the body goes into automatic, and we're actually someplace else doing whatever we do. I don't remember those things, but anyway, I was trying to map out to work with my mouse traps, if you will. Okay, and I say mouse traps is the understanding how I'm going to construct a buzz box from these sizes, and the mirrored reflection as we learn through. Now, in teaching this part of syllabus that this will be written into, I think it's really important, because I see in my mind's eye, and I've got to get it from that level that's out there that I haven't seen in this physical realm yet, but the mechanics of where I can teach what's going on within the PMH. And the the reference in the PMH in the ferrous material in the center, about the center, there's one atom, if you will, of iron material that directs all the other atoms in that same material to polarize, and they're reluctant to do it, but that one directs them, and that's the energy of being directed one side or the other. In the that's the rotation of spin, if you will, whether it being clockwise or counterclockwise within the coil. And so when you're dealing with electrics and magnetics, it's a coil, and it really doesn't care which way it's wound. Does it give a different point of view in being watched? Certainly it does. I mean, just like right now, this says chili, and it's written backwards like a mirror reflection. In other words, when I'm looking into the screen, I see a mirrored reflection that actually, this is my right hand, and so it reads from right to left if I'm going to interpret it. But then when we see it on the screen, it's going to be left to right, and there's a crossing over that mirrored to unmirrored that gives us a different point of view of that mirrored reflection. So, you know, part of the things that I'm talking about is going to be what I term mirrored reflex memory. And it's just like when you drive into a mirror, see yourself in a mirror, if you will, you know to stop because there's a mirrored memory reflex that, you know, you can feel it. You know that there's something there that, you know, and so you'll hear me say a whole lot of times that sometimes you're the windshield and sometimes you're the bug. Okay. And I'm going to put together some tools in this presentation to where you can work with it yourself, prove it to yourself. But the getting to understand that zero in the plane and zero in the mathematics being infinity, there is a quantum function of zero. It's like, you know, you could look at it as a point of origin, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, in the quantum vortex math, if you will. But it's, you know, positioning reference of where you are in that media. What's really neat about the Model T spark gap is, like I said, you know, they tune those things to handle 1.2 to 1.4 amps. Okay, and that was with I believe it was actually 6 volts of, it may be 12 volts, but they use dry cell batteries. And the dry cell batteries would last a very long time in that configuration. And as we're learning more about activated carbon, we can see why, because once the system was started up in the magneto system, it would actually send voltage to that positive terminal on the dry cell batteries, and they weren't actually discharging it, just they were using that dry cell battery as the with the carbon anode as the resistor. And so, as we've learned in previous units, talking about asymmetrical motors, what I term as metronomic motors, and the configuration of the winding of the armature in those, which I've basically taken off the shelf parts, rewound them to another dimension with a completely different bisector, and finding the 0 point within that. And a lot of you know that's worked with generators. You would find the 0 point of the two brushes on the opposite end to where the generator didn't want to spin clockwise, didn't want to spin counterclockwise, and then also didn't want to vibrate back and forth. Okay, so all those things are present in that dipole. Okay, and that's what we're getting back to, is the dipole, and that dipole is the neutral, if you will. It's not biased. It's not biased to the current or the way that the motor or generator is wound. Okay, it's the neutral point within that. That's a 0, and then the other angle was tuned to the amperage that would handle that through the, and that's actually a symmetrical wound generator. Asymmetrical works a little bit different. I haven't found all the parameters with that yet. I'm still in the learning phases of understanding iron in the system, understanding aluminum in the system, understanding carbon in the system, the copper in the system. There's so many things to consider now that the bias section of keeping that plane to where you just have a 180-degree dome over that plane. Okay, and that leads us right back to the protractor, and which leads us right back to the dome type technology, getting away from symbolism and everything else, but the actual tapping from the ground plane, if you will, with asymmetrical technology, we've got to find where that 0 plane dimension is, ZPD, and overcome the biasness of the system. And that's going to lead us into memory, mirrored reflex memory, or the MRM. And then that technology will lead us into the quantum mirror, the TQM, and then we can understand how to build quantum memory mirror, the quantum memory mirror with the QMM. So there's lots of things in here that will really send some people's minds reeling, especially people that have studied quantum physics all their life. And then all of a sudden you have a guy that comes up with a different technology and understanding that, and then also that has the capability of working out the mathematics to prove what he's telling you. So we're working with electric technology, ET, okay, and we're discovering sympathetic resonance within the system, the SR, and then we're going to gain the spring-loaded, or the SL technology within that memory, and we're going to discover what the 0 plane dimension within that dipole is. So the Iron Age is discovery of what makes us accelerate to learning the different things that we have in the technology field. It's actually going to be very fun and exciting, I believe. the biased side of it, whether you're wanting a right hand spin or a left hand spin. To me, the magnetic field, once it runs through the coil from whatever potential, it's a mirror, and it really doesn't care. It doesn't have really a different sound, other than it does have a different look. And so knowing something inside out, backwards, upside down, and then the mirrored reflection of it as well, that's a whole new dimension to me that I'm coming up with. And then, like I said, mirrored reflex memory. The whole thing boils down to the hysteresis model that iron has. And again, I got to thank Scott Russell for getting me tuned in to that and unfolding Merlin's hat and the getting what the idea of the envelope of the system is, and putting all those things into writing to get that message of Merlin's hat into people's hand, taking the low-tech technology, keeping it simple, and then teaching that that toy model to do that. So anyway, like I said, covered here in about 16 minutes of what I wanted to talk to you about. So many things that people have published these drawings that should have been published a long time ago. And the reason they weren't is for good old-fashioned money, and kept in reserve. But there's been a lot of jobs and livelihoods created just by people that had that diamond, and they released bits and pieces of it, and without giving the whole overall to it. They had to produce some of it, put it right there in plain sight for people to see. But I am now convinced that the Model T, the motivation spark, if you will, was derived from that coil. And so, like I said, had a iron memory, and it was wound one way, and then the wire runs straight back to it, wound the other way, wire straight back to it, then wound the other way, wire run straight. And that's going to stop the eddy currents. That's going to give us the 180-degree look of what they were doing that in the primary coil. How many layers that is, I suspect it's about 6 layers. It could be 9. In overcoming the ignorance that I have, it's just like in a pile. 1 ferrite was 1 square mile, so that's 5,280 feet square. Okay, and 6 inches deep for the separator, if you will, and that was considered 1 ferrite of 1 farad. 1 farad of capacitance. Okay, well, that was 1 square mile, and then 1 inch off the ground. And I still haven't got that down, but when you do the multiplication of getting that to inches, you've got 126,720 square inches, and then 1 square inch in that mile unit of separation to create the 1 farad. Okay, and so when you boil all that down, as far as what you're in the model of 360 degrees divided by 8/1, that's 360/8, which gives us the overlooked plane, there's the plane of zero being in there with 3 on either side of that plane. And so getting to understand what we call a farad, now we can do it, very small, one farad capacitor, but understanding the energy that's left in that dimensionally is pretty cool. So the understanding where the current comes from and how, a series circuit, how voltage leads current, and with a capacitor, current leads voltage. Okay, and then running that through a resistor, where those two are becoming in phase at 90 degrees in there. So what about that 45 degree in between that 90 degree spectrum? So the we're learning more about the way the electric technology works. Just things that are overlooked. Yes, we have formal education, but we don't really understand how to use that without, if you will, civilization. Okay, and the basics of simplicity is that what I'm wanting to learn and teach is that without civilization, knowing what components that you're looking for in the environment or construct that you're in, to where you could MacGyver a lighting system, generation system from common materials that are from that construct. And so because memory, as far as what we get to keep, is very small, and or it was this go around for me. Hopefully I'll retain more memory on the next go around, but I don't want to fight the battles that I did before with understanding iron. And so it's part of my education, learning what it is I'm supposed to learn, can't earn or deserve it. It's a experience thing. And as we walk hand in hand together, learning these things, it's a joy and a pleasure to be able to understand that. So with that, I'm going to sign off. I always say, hope you're having fun, because we are.